Hi all. So I hope everything is clear about your electrolytic cell. In this particular video, we'll be covering our next topic, which is your Faraday's law. So Faraday gave us two laws. Faraday's law. Faraday gave us two laws. Faraday's first law and second law. Will not be doing more questions for second law because everything is related to your first law only. The questions will be similar only. So let's study what did Faraday told in his first law. So you all know what is you all know what a electrolytic cell is. You're passing electricity, and on passing electricity you are getting chemical compounds, right, at the anode, at the cathode. What does Faraday's first law tells you? The definition tells you the mass of the substance. The mass of a substance deposited. Mass of the substance deposited or the mass of gases liberated. Or the mass of gases liberated at a particular electrode is directly proportional to the amount of current passed or the amount of charge passing through the solution. The charge passing through the solution. In short, if you want to write, what does it mean? The amount of mass, whatever is getting deposited, is directly proportional to the amount of charge. More charge you are passing, more mass you will be getting. Now it's a proportionality sign, right? So you must have studied in physics and maths, everything, like wherever proportionality sign comes and you want to put an equal sign, you will write a constant, and this constant is a z here. So z is actually your constant, which is called as electrochemical equivalent. This is called as your electrochemical equivalent. Now for q, if you want, like charge's formula is q is equals to it, right? That is current equals to charge into time. So just substitute your second one in first. Substituting your second one in first, what you will be getting? M equals to ZIT. So either this formula you can use or you can use M is equals to ZQ, one and the same thing only, because Q is equals to your IT. So these two are the formulas given by the first law of Faraday. He told that the mass of the substance which is deposited or the mass of whatever gas is liberated will be directly proportional to the amount of charge you are passing through the solution. Okay, now this Z also, Z is equal to E by F. Just remember this thing. Z is equal to your E by F. And your E is your equivalent weight. Now, like if you study in your molar concept, equivalent weight equals to your molar mass by N. Molar mass by X. X is your electron number of electrons transferred. F is your charge on 1 mole of electron. F is your charge on 1 mole of electrons, and which is equal to your approximately equal to your 96500 coulomb. So if you substitute everything, you will again get a new formula. M is equals to E by F IT, or your M equals to molar mass upon X into 1 by F into IT, right? So these are the formulas which you need to use. Just remember one formula. Rest of the formulas can be derived from the same formula. So just a quick revision of all the formulas. We studied the amount of mass liberated is directly proportional to the amount of charge you are passing. You know charge equals to current equals to I into T. If I want to remove the proportionality sign, I'll be getting M equals to ZIT. Z is your equivalent, electrochemical equivalent. And here Z equals to your E by F. F is the number of moles of charge on 1 mole of electron. Whatever charge is having on 1 mole of electron. Charge on 1 mole of electron is called as 1 Faraday, and which is approximately equal to 1 Faraday is equal to 96500 coulomb into IT. And what is your E? E is your equivalent weight. We know by molar mass concepts that equivalent weight is equal to your molar mass divided by X. X is your number of electrons transferred into your 1 by F into I into T. So these are the formulas which, like any of the formulas, can be used to come into the conclusion of the answers. Okay, so let's do few questions from our course. The first question is, find the amount of copper. Just check what is the question asking us. You have to find the amount of copper. Find the amount of copper deposited. You have to find the amount of copper deposited when 5 ampere current. When your 5 ampere current is used for 1 hour to electrolyze CuSO4 solution. Now what is given is, you already know 1 Faraday is equals to 96500 coulomb, and what is given? The atomic weight of copper. Atomic weight of copper is given to you as 63.5 grams. So firstly we'll write what is asked for us and what do we need to find. Find the amount of copper. Amount of copper means they are asking us the mass, right? They are asking us to find the mass. Deposited when 5 ampere of current. Ampere means I, right? 5 ampere is the current, is used for 1 hour. What is the time? Time is 1 hour. 1 hour has 60 minutes and 60. Like if you want to convert it into seconds, multiply it by 60. All these things are given to you. You need to find the mass. Can we find the mass directly by using the formula? M equals to ZIT. Now I and T are already given to us, so we don't worry about it. What is Z? Equivalent weight by Faraday, right? 1 Faraday. And how will you write this CuSO4? In CuSO4, your copper exists as Cu2 plus ions, correct? So here your Cu2 plus ions will act like 2 electrons. 2 electrons are there in the X. So Z you will write it as E by F into IT. And your equivalent weight is molar mass divided by X. Molar mass divided by X into 1 by F. F was remaining here, that's why into I into T. What is the molar mass of copper? 63.5. X is your number of electrons transferred is 2. Faraday is 96500. Then I is your 5 and time is 60 into 60. You solve this thing and you will be getting your weight. What will be your weight? It will be equal to, like when you solve it, you will be getting 5.8 gram, and this will be our answer. So this is by direct use of formula. What was already given to us? I and T was given. We know the number of electrons transferred in copper will be 2. We know the time, we know the current, we know the molar mass, everything we know. Just substitute the values in the formula, you will get the answer. Now the same questions, all these kind of questions can be done by unitary method also. How do we do it by unitary method? Like we have already got the answer. Now this is the other method which I am showing. This is your unitary method. How will you do it by unitary method? See, you know the reaction, right? You know the reaction. Cu2 plus is accepting 2 electrons to give you copper. How many moles of copper? 1 mole. And 1 mole of copper, you know, is equal to your 63.5 grams. 2 electrons means 2 moles of electron. 2 moles of electron, and which means your 2 Faraday. Remember, we studied 1 mole of the charge on 1 mole of electron is called as 1 Faraday. So charge on 2 mole of electron will be equal to your 2 Faraday. Okay. So they are asking us the amount of copper deposited, right? Now 2 Faraday is giving you 63.5 grams. 2 Faraday is giving you 63.5 grams. What is Faraday equals to? 96500 coulomb. Because 96500 coulomb is giving you 63.5 grams. How much will be 1 coulomb equal to 63.5? Just cross multiply. Divide by 96500 multiplied by 2, and this is your 1 coulomb, right? Also we know that your Q is equal to your IT, right? I is already given to us. T is already known to us. 60 into 60. So this particular thing, what is this particular thing? 5 into 60 into 60 will be equal to, like, will be giving you how much? 63.5 upon 96500. See, if 1 coulomb is giving you this much, same unitary method. So this much coulomb will be giving you how much? This into the same numbers, 5 into 60 into 60. So this will be equal to your 5.8 grams. Same answer. Yeah, same answer, 5.8 grams. Understood? How do we do the unitary method? First, we write the reaction, whatever reaction is happening. So 2 mole of electron is giving you 1 mole, that is 63.5 grams. This means 2 Faraday. 2 Faraday is giving you 63.5. If we need to convert Faraday into coulombs, we know 1 Faraday equals to 96500. 2 Faraday will be equal to 2 into 96500 coulomb. So 1 coulomb is giving you this. How much this coulomb will be giving you? Multiplied by the same thing. Like 1 banana is equal to your $20. So 2 by 3 bananas will be equal to 20 into 2 by 3. Right? Same thing. Same unitary methods you are applying here to directly get the answer. Okay. Next question. Next question is telling us 2 Faraday of electricity. 2 Faraday of electricity is passed through the solution of CuSO4. Is passed through the solution of CuSO4. Same thing, only it's asking the mass of copper deposited. The mass of copper deposited at cathode is. Atomic weight of copper is 63.5 grams. If you directly want to do it by formula, you can do it by formula also. Mass they are asking, right? Mass we don't know. I is your I is not given actually, directly Q is given, right? Q means Faraday. Q is equals to 2F and time is also actually not required. So M is equals to your Z into Q. What is Z? Z equals to your E by F into Q. What is Q here? 2 Faraday, right? E by F into 2 Faraday. F and F get cancelled. 2 times equivalent weight will be your answer. What is equivalent weight here? 2 into 63.5 divided by 2, which is will get cancelled, and you will get 63.5 grams. Okay. You can do it in other fashion also, like Cu2 plus 2 electrons unitary method is giving you copper. 2 Faraday is giving you 63.5 grams, right? Like 2 moles. 2 Faraday is already giving you 63. Now they are asking directly for 2 Faraday electricity only. So 2 Faraday will be same only. 60, like directly you can do it. 63.5 grams. Third question. Third question is telling us electrolysis of dilute aqueous NaCl was carried out using 10 milliampere of current. Milliampere, okay? Milliampere of current. Now what are they asking? The time required. They are asking us the time required to liberate 0.01 mole of H2 gas at one of the electrode is. They are asking us the time required, right? Now if I want to directly do it from the formula, what are they asking? They are asking us the time required, right? How much ampere of current it is? I is equals to your 10 milliampere. What does 10 milliampere means? 10 into 10 to the power minus 3. And how many moles of H2 is there? 0.01, right? Zero point zero one. What are we going to do? We know like NaCl, electrolysis of what thing is happening? NaCl's electrolysis is happening. So NaCl is getting split up into Na plus and Cl minus, and similarly your H2 is getting split up into H plus and OH minus ions, right? Now the time required to liberate 0.01 moles of H2. So how will firstly the H2 form? H plus plus 1 electron, like 2 H plus plus 2 electrons will have to do to give you H2. Correct? We cannot do H plus plus electron, otherwise it will give half H2. But we need H2, so we are doing 2 H plus plus 2 electrons. Now just take this reaction. In this reaction, 2 mole of electron is giving you 1 mole of H2. This means 2 Faraday is giving you 1 mole of H2. How much moles of H2 we want? 0.01 mole. So 0.01 mole of H2 will be giving you 0.02 Faraday. Right? And what is 1 Faraday equals to 96500 coulomb. So same things will be writing Q is equals to I into T, right? Here your Q is your 0.02 into 96500 multiplied by T. That is your Q here, right? And your Q, like exactly actually is given to you as, this is your Q, milliampere. Yeah, ampere is the unit of current, right? So this will be your Q. Q is your I into T also, and Q is already given to you as this. So just equate this. So 10 into 10 to the power minus 3 equal to 0.02 into 96500 multiplied by T. Just find the value of T. This will come out to be 19.3 into 10 to the power 4 seconds. So what was the actual question? The electrolysis of NaCl was done using 10 milliampere. What does milliampere means? Milliampere means here 10 into 10 to the power minus 3. Electrolysis of this thing is done. What do we need? To the time required to liberate how much hydrogen? 0.01 mole of hydrogen. So what is 0.01 mole of hydrogen? How will we get liberated? If we give 0.02 Faraday of current. Just use the formula, use the unitary method, that Q equals to, this is your Q, actual Q given to liberate 0.01 moles of hydrogen, will be equal to your I into T. I was already given, like Q into T. This is already given to you, right? Q is given is equal to I, this is your I, and multiplied by T. And just then find the value of T. You will be getting 19.3 into 10 to the power 4 seconds as the answer. Okay. I think this one will be the last or second last question. This is a big question. Yeah. Let's do this question. The question is telling us 4 molar aqueous NaCl is prepared. 4 m of aqueous NaCl is prepared, and your 500 ml of this solution is electrolyzed. 500 ml of this solution is electrolyzed. So after evolution, what happens? This leads to the evolution of Cl2 gas at one of the electrode. This leads to the evolution of Cl2 gas at one of the electrode. Now the atomic masses are given. For Na is 23, for Hg it's 200, and for 1 Faraday you know it's 96500 coulomb. What you need to find? The first part, it has different parts. The first part you need to find total moles of Cl2 evolved. Total moles of Cl2 evolved. This directly you can do it. See, you know molarity equals to moles of solute dissolved in a liter of solution, right? Number of moles dissolved in volume of solution, correct? The number of moles dissolved in volume of solution. How much moles is given to you? 4. Number of moles is given mass by molar mass, or we just need to find number of moles, then we can just keep it as X. Volume is 500 ml, right? So 500 divided by 1000. This and this get cancelled. 5 to 1 by 2. So this you will be getting 2 moles of NaCl. So now you are getting 2 moles of NaCl, right? Among these 2 moles of NaCl, what is happening? You are getting 2 Na plus plus Cl minus, 2 Cl minus. If you are taking 2 moles, you are getting here also 2 moles and 2 moles, right? But what are they asking us? How much is Cl2 liberated? How will we calculate Cl2? Take this Cl minus, write the reaction. 2 Cl minus is giving you Cl2 plus 2 electrons. So your 2 moles is giving you 1 mole, right? So the answer will be 1 mole. Understood? Like 4 mole of HCl you are preparing. Out of this you are just taking 500 ml. 500 ml of this solution, and you are electrolyzing it. Now in this, your chlorine gas is liberated at one of the electrode. You need to calculate the total moles of chlorine. So see, just write molarity here. Number of moles, volume of solution. You need to find the number of moles of NaCl first. Whatever you found the number of moles of NaCl, write the reaction, find the moles of Cl minus. After finding the moles of Cl minus, write this reaction to get the number of moles of Cl2. So what is the number of moles of Cl2? Number of moles of Cl2 is 1 mole of Cl2. Okay. Now the second part of the same question. Second part is telling us if your cathode is mercury. If cathode is your mercury electrode, the maximum weight. If cathode is mercury electrode, the maximum weight of amalgam, formed from this solution will be. What will be the maximum weight of amalgam? You remember this was the case 3 which we had done in the previous video. Now see, NaCl is getting electrolyzed into your Na plus and Cl minus. We already studied it. We started from 2 moles, right? 2 moles. And here it was 2 mole. Now Na plus will be accepting an electron to give you Na. Same thing, 2 mole is giving you 2 Na. Now your 2 Na will be combining with 2 Hg to give you 2 NaHg. 2 moles and this also 2 moles. The weight of, I think, Hg was 200. So 2 moles means 400, right? 400, this becomes your 23 into 2, 46. So the total will be 446 grams, right? Third part. Third part is telling you the total charge required for complete electrolysis. The total charge required for complete electrolysis. We studied 2 NaCl was giving you 2 Na plus and 2 Cl minus, right? Just write both the reactions. 2 Na plus 2 electrons. 2 electrons is giving you this, means 2 Faraday. Here also 2 Cl minus is giving you 2 electron plus Cl2. 2 electron means 2 Faraday. So total charge is 2F. For both the reactions we need 2F. Okay, next question. Next question is telling us a current of 2 ampere is passed for 1 hour. So current is there, you are passing this for 1 hour through a solution of AlCl3. Through a solution of AlCl3, which is molten and has a current efficiency of, so they are not giving us the current, they are giving us the current efficiency, and it has a current efficiency of 50%. Find the amount of, what do you need to find? The amount of aluminium deposited at cathode. The current of 2 ampere is passed, right? For 1 hour. Now first write is the reaction of AlCl3. What is happening in your AlCl3? It's giving us Al3 plus and 3 Cl minus. At cathode, what is happening? At cathode, your Al3 plus is accepting 3 electrons to give you Al. Means here you're using 3 moles. What they have given us, they have given us efficiency neta, that's called as neta, is the efficiency. This is equal to your I input by I output. Into your 100. Efficiency they had given 50. I input by I output. What was the I output? 2 ampere, right? 2 ampere was passed. So 2 ampere into 100. On solving it for I in output, sorry, this is I output by input. So your I output will be 1 ampere. So by formula now you know M is equal to Z into Q, or we can directly write it as E by F into I into T. What is E of aluminium? Definitely 27. Faraday is 3 into 96500. I is your 1 and this is your 60 into 60. What is it equal to? 0.133. Okay, so a current of 2 ampere is passed for 1 hour through a solution of AlCl3. These are, all the kind of questions which might come. These are like high order thinking skills question also. So you can use it by formula as well as you can use the unitary method also. So AlCl3 is giving you Al3 plus plus 3 chlorine. At cathode, what reaction is happening? Al3 plus is accepting 3 electrons to give you Al. Here you are having 3 moles. Eta is the efficiency. I output by I input into 100. I output you need to find it out, which will be equal to 1 ampere. After this, just substitute the values, you'll be getting the mass here. You can solve this particular question by your unitary method also. How will you solve it? You know Al3 plus plus 3 electrons is giving you Al, right? This is your 3 Faraday. Just remember this thing is happening at cathode, right? Deposited, because that's why we are taking this particular reaction. So 3 into 96500, 3 Faraday, right? 3 into 96500 is your 27 grams. So 1 coulomb will be 27 upon 3 into 96500. How much coulomb they want? I into T, right? 1 into 60 into 60. Q is equals to I into T, right? I is your 1 into 60 into 60. That's what we calculated. Will be equal to this thing into 1 into 60 into 60. Okay. Next question is a multiple choice question. Now it's asking you a charge of 1 Faraday deposits. A charge of 1 Faraday will deposit how much? 1 mole of substance, 1 gram of substance, 1 gram equivalent of substance, or your 1 AMU of substance. So you know M equals to Z into Q. A charge of 1 Faraday, right? They are asking about 1 Faraday. So what will you do? M equals to E by F. Now 1q equals to 1f, right? So m equals to 1 Faraday. This and this gets cancelled. So mass is equal to your equivalent mass. A charge on this thing deposits, mass of substance is equal to your equivalent mass. So 1 gram equivalent of substance will be the answer. Equivalent mass. Okay. Now we come to the second law of Faraday. What does the second law tells us? Second law is exactly the opposite. Second law tells us if same amount of electric charge is passed through different electrolytes, then the amount of substance deposited or liberated is directly proportional to its equivalent weight. See, what was the first law? That the amount of mass deposited is directly proportional to the m is directly proportional to your q. This one was your first law, right? Mass is directly proportional to your q. What is the second law telling us? The same amount of electric charge is passed. If you are passing the same amount, just the opposite, same amount of electrical charge you are passing, then amount of charge substance liberated is equal to your equivalent weight. How do you write it down? How do you explain it? You have two containers. One is of ZnSO4, the other one is of CuSO4. They are connected through a battery. And you have a series connection so that you get same amount of charge everywhere. So I is same because it is connected to the series. I will be same because it is connected in series. Your time will be same. So Q to definitely it is same. I into T is same, then Q will definitely be same. So how do you write it? M of ZnSO4 equals to your Zn Same thing, Z into Q. M equals to E by F into Q. Just write of zinc specifically. Similarly, M of copper will be equal to your E of copper upon F into Q. So compare these both. What will you get? That your mass is directly proportional to your equivalent weight. That's what your second law tells you. Same amount of electricity you are passing, the amount of substance deposited, m, is directly proportional to your equivalent weight. The same amount of questions comes in your course. So if you have enough practice of first law, the second law will be easy for you. Practice the same questions. Okay. So that's it for your Faraday's law. Just remember, Faraday's law means the amount, first law means the amount of mass deposited is directly proportional to your charge. That is, m is directly proportional to your q. You arrived at many formulas here. M equals to ZQ or ZIT, or Z was equal to your E by F into I into T. E was equal to your molar mass upon X into 1 by FIT. Right? Here what is the conclusion? If you are passing the same amount of electric charge, the amount of substance, whatever m, is directly proportional to your equivalent weight. That's all. And this we have got from this formula. M equals to ZQ, you do. expanded, you'll be getting M is directly proportional to equivalent weight. Okay, so that's it for your Faraday's law. So in next chapter, next video, we'll be studying mostly about your electrolytic conductance. Okay, so thank you so much everyone.